In this session we will solve a problem based on air core solenoid, wherein we will be finding out what is the self-inductance of air core solenoid. Now first take down the question. This is an examination problem. Derive an expression for the self-inductance. Derive an expression for the self-inductance of a long air core solenoid of length L and number of turns N. Derive an expression for the self-inductance of a long air core solenoid of length L and number of turns N. Now we need to find out what is the self-inductance. Now just recall what is self-inductance. We know self-inductance is given by, it is the flux linked with the coil, total flux linked with the coil divided by current, right? L is N phi by I. That is the basic definition of the self-inductance. Self-inductance of a coil is equal to the total magnetic flux linked with the coil when unit current passes through it, or it is Weber turns per ampere. Weber turns is total flux which is linking the coil. Now we will consider an air core solenoid, and given that the length of the coil is L and it has N number of turns. These are all given. L is the length of the coil and N is the number of turns. Now we will assume that a current I flows through this coil, and let us say A is the area of cross section of the solenoid. Now N is the total number of turns in the coil, and L is the length of the solenoid. So now let's say A is the area of cross section. Okay, this will assume A is the area of cross section. If you supply a current I through this coil, now what will happen? Now you know, when a current flows through a solenoid, there it sets up a uniform magnetic field, right? And the field is given by B is mu naught Ni. The solenoid will act as a magnet. One side will be north pole, the other end will be south pole. And when you calculate the field inside the solenoid is uniform and it is given by B mu naught Ni. Let us assume that a current I is passed through the solenoid. So we can write this: when a current I flows through the coil, or if I current flows through the coil, the magnetic field is given by, when current I flows through the coil, the magnetic field which is set up is given by flows through the coil, comma, magnetic field is given by, magnetic field which is set up is given by setup is given by B is equal to mu naught small n into I. But what is the small n? This is number of turns per unit length. Small n is number of turns per unit length. Small n in terms of capital N is given by small n is capital N by L. Now why do we need this B? Why did I write B? Because we know for me to calculate self-inductance L is equal to N phi by I. So I know, and N is the total number of turns. Now I have to calculate what is the flux linking the coil. To calculate flux, I have calculated what is B. That's the idea, to find out the value of B. Why did I calculate the field strength B? Because to calculate phi. Now next we will write what is phi. Magnetic flux linked with each turn. Is B is equal to, or is phi is equal to B into E. Therefore phi is equal to, this is flux linked with each turn or one turn. B is mu naught Ni into E. Therefore self-inductance or coefficient of self-inductance L is, substitute L is N phi by I. We have L is N phi by I. I'll write here, by definition L is N phi by I. Now N into what is phi? That is mu naught N into I into A divided by I. Now here I will cancel and we get L is equal to mu naught N into mu naught N into Na. Now we'll write this N will replace by number of turns and the length of the solenoid, because we always have to write the answer in terms of the given quantities. The given quantities here are the total number of turns capital N and the length of the solenoid. So now substitute N equal to N by L in the above equation. Now what do you get? L is equal to mu naught into N into N by L. Sorry, here I got cancelled. It should be A, not I. This is A. Okay, please correct it. L is mu naught, because I got cancelled and the remaining term was A. Mu naught into N into, I'm sorry about it, so just correct it. Instead of I you write A, because I get cancelled. Mu naught into N by L into A, and this gives rise to mu naught into N square A by L. This is the self-inductance of a air core solenoid. So finally you can write self-inductance of air core of a long air core solenoid of length L and number of turns N is Ls equal to mu naught N square E by L. Remember this equation, we may need for some more problems. This is how we calculate the self-inductance of a air core solenoid. Mu naught L is mu naught N square A by L, or mu naught A N square by L, whatever. Now if you have a solenoid with other magnetic material whose permeability is given by mu r, then you have to multiply this equation by mu r. This is air core where mu r equal to 1, hence this equation. L is mu naught A N square by L. This is an important derivation, hope you understood this, and this is a required expression.